In this video we're going to make a spiral or snail cam. First I want to look at the image of what we're going to make, a sketch. So this is our cam, and let's look at some of the dimensions on there. First, you'll see that there appear to be two circles. There's a small one and then there's a large one. And so we're going to start by using this smaller circle in here as the fundamental feature, and we're going to define a radius for that smaller circle. That'll be the thing that we defined in the table as a user-defined parameter. And then we're going to make the larger circle, which you'll see in a moment, a certain amount bigger, in this case 0.5 inches. And you'll notice that there are actually four distinct arcs that go into making the outer portion of this. So we're going to make 4 arcs, and we've got the center axis. We're going to have a square hole here. This one is circular, round. 0.1875 is 3/16, so put that into either one of these into your parts so you get the correct volume. 3/16 is probably better, and this thing is 3/16 in thickness. So let's start making this. First thing I'm going to do, since I want to make this using parametric constraints, is I'm going to go to the parameter table and I'm going to define a user parameter called base radius, and I'm going to let that be 1.0. I'm not going to comment this. The name is a little self-explanatory. Okay, so we have a base radius. So let's begin by placing a sketch on the XY plane, and we're going to make 2 construction circles. So construction circle. The first one I am going to make equal in radius. Notice that I'm on radius now. Right click, diameter. Now I'm on diameter. Right now I want to be on radius, and I'm going to put in base radius, and that's going to be equal to 1.0. As we've seen, we just defined that. I'm going to make another circle concentric to that, and in this particular case I'm going to make it 1.5 times the base underscore radius. Alright, so I have these two diameters, and what I'm going to do now is take a look at my parameters table, and you can see that I've got the base radius 1.0 and then the subsequent parameters that get created when I dimension anything in Inventor, starting at D0 goes to D1, D2, D3, D4, etc. We have base radius and 1.5 times the base radius, so everything looks good so far. At this point I am going to leave it like that, and we're going to continue on. So we're going to get out of construction mode and go into object lines. So I'm going to make a line here like so, and I want to make sure that this line is directly above the origin. So I'm going to use a vertical constraint of that point with that point. And now I'm going to start making those 4 arcs. It's going to start here and it's going to end up here, as you might expect. So here's our first arc. I'm going to click here, and I'm going to click about 1/4 of the way out between them there, and then pull up to about like that. Now you'll notice that right here I wasn't sure that I was really horizontal with the center, and I want to be. So I'm going to use a geometric constraint of horizontal to go here to there, and There we go. So now I'm going to make another, and actually what I'm going to do, I think the order I want to go in is I actually want to dimension the distance from here to here, and that's going to be some value. I'm just going to leave it whatever it came out to right now. Now I'm going to come and make another arc from here about halfway out down here between the two. So right there, right there. Now I'm going to make that point, make sure it's right underneath the origin, like so. And I'm going to dimension it here to here and just pull out there. For now, I don't care exactly what that number is. And we're going to continue. We'll go 3/4 of the way out, and we'll put it right there. And again, I'm going to use the horizontal constraint to make sure that ends right at a place that's horizontal to the origin. And again, I'm going to dimension from here to here, like that. And finally, I'm going to make the fourth arc from there, and then bring it home and close it and do something like that. Okay. Now, you'll notice that right here, we typically have a right angle here. In other words, this initial arc is tangent. Is tangent to this circle, which would make it perpendicular to this line. So I'm going to use the tangent constraint between here and here to bring that into line. Now at this point, I am going to, let's see, there might be a better order in which to do this over other ones. For right now, actually no, I'm going to go up and I'm going to set those distances here. They just came out randomly based on where I placed the end of the axis. So here's where really the crux of this assignment comes in. We're going to work with the parameters table. So I've got a base radius that defines fundamentally my snail or spiral cam, and that's equal to 1 inch. And so I have all that taken care of here. I decide that I'm going to make the radius of the bigger circle, so to speak. The circle kind of disintegrates, you know, has the radius out here, and then it gets smaller and smaller. At any rate, I'm going to call this one R1 and call this one R2, because I'm going to use those in equations to define these distances here. For example, D2 is this 1.135. So I don't want it to be that, and in fact I'm going to give these names. So arc1, arc2, arc3, and while we're documenting here, so this could be called the smaller radius, and R2 could be called the larger radius. Arc1 is the small arc. This one is the middle arc, and this one is the large arc. You can see 1.394 is that one, so it's the bigger one here. And then I'm going to use an equation here. So I want this point to be 1/4 of the way out between these two circles. Okay, and then it'll be 1/2 of the way out here, 3/4 of the way out here, and of course all the way out here, which I won't need to worry about because it's already there. So here, just watch closely. I'm going to say R1 plus 0.25 times the difference between R2 minus R1. So enter, and I haven't updated it yet, but when I finish this, these will update. So I'm going to do a Control C, and I do a Control V, into each one of these, and I'm going to come in here and change this multiplying factor to 0.5 there and to 0.75 here. Remember, these are the arcs. As they increasingly get bigger, I'm taking them and they're intersecting at 1/4 of the way there, 1/2, 3/4 between the two construction circles. So if all things are okay, if I hit OK, and then I have to come up here to the local update, those numbers should change, and they did. Okay. So in terms of dimensions, I think we're okay. We've got the correct parameters table. If we come up here, we can change the base radius to a different number, and the cam should change and still be usable, because it will just get bigger in all dimensions, relative dimensions. So now I think it's clear what we're missing is that these really need to be tangent to one another, these arcs. And oops, what happened there? I think this one has to be tangent to there. Okay, that doesn't work. Okay, so what's wrong here? We got 2 dimensions left, and I think what I may have forgotten to do is make sure that that one is vertical with that one. Oh no, that's already taken care of. Okay, so I'm going to be very angry if this video dies on me here. So what is going on here? So let's see, this one has to be tangent to that one, but where did it go? I don't get that. So let's do a Control Z, and if I go from here to here, it's probably already constrained to be 1.5. Yeah. Cancel. So what am I doing wrong here? Let's see. I want to finish the sketch, and that's clearly not what we want to have. This has got to be smooth, but it's got to stay attached there. I don't understand why that won't do that. What if I finish the sketch? What if it's gone? Incredible it is. So let's undo that. Go back into the sketch and try to figure out what's going on front. So it has something to do with not being affixed here. I've got 2 dimensions needed. Let's go here and look at this, show all degrees of freedom. So this one can come out. It's not attached. I think I just didn't quite get it to click on there. So let's use the coincident constraint between there and there and see if that'll save me. Now let's do the tangent here to here and here. Yes. Okay. So you can see that little bitty things that you forget will get you in trouble. So when I made this final arc, I didn't quite make sure that it was coincident with this vertical line here, which is kind of obscured by this annoying dimensional notation here. Okay, I think we're okay, so let's finish that. Let's extrude. Let's do a symmetric extrusion of thickness 3/16. There it is. Okay, now let's make the we're going to make the axle hole using the hole function. So I'm going to put a point right in the middle, right there. Finish the sketch, and there's my hole. And so there it is, and I want that to be 3/16. Okay. Now this one should have, now of course you want to save this first before you screen capture so I can see your name here. So I'm going to save it. Smith John _ forgot what I had you call it. Snail cam. Snail cam. Is that it? Snail cam. Save. And what's the volume supposed to be? Looks like it's supposed to be 931.931 cubic inches. And let's keep our fingers crossed. iProperties physical update 0.931. Okay, so there we go. So when you turn this in, you might want to push these together. You're going to have to find a way to get these two things, four really, the browser, the part, and the physical tab of the iProperties window, as well as your table. So it should look something like this. Notice also that when you make the image file, I want you to put your grade, or sorry, your class, fourth period puts a 4, sixth period puts a 6. I'll explain why I do that in class. But that is today's assignments. Thanks for watching.